Okay, I'm going to try recording this for the third time. I hope this will work. We're doing limits worksheet 3, and we're going to use the Desmos app. You can download that on your phone. I first want to look at problems like 3 and 4 where you have a denominator. First off, what you're going to see is that you need to come over here to this app, this little window there, and press it so I can get a keyboard. Whenever I have a numerator of more than one term and then a denominator, I need to start out with a parenthesis. So I'm going to do the problem x minus 2 all over x squared minus 4. So I have x minus 2. I can choose to close the parenthesis, or I can right arrow out of the parenthesis, divided by, and now I'm going to go to x, and here's my square key, minus 4. Now, if you're using your computer, you can use your keys on your computer. Now, I want to create a table, and because I've given you the numbers, so this cute little wheel here, you go up there, you'll see a done, and now you'll see a table, so you can get a table. I don't like those numbers in the table, so I'm going to go over here, and notice I can go to my cross-out key, and now this one I'm just going to do a type over. So I'm going to start with 1 point. Just this would already be in your table. You would just copy them in, and then I can use this key just to go to the next line. And so I'm just putting in values that you would be reading out of your table as I do these. So you'll just be copying in, typing in what you see already. And so now, what you'll notice that these are all glummed up right there. You could see the points going on while I was presenting it. I believe you were able to see those. I'm hoping you can. And so you can see it looks like we're all converging on the same place right here, 0.25, 0.25, 0.25. Here, notice 243, 249, 2499. And if I put in more zeros, I'm just going to get more 9. So this is approaching 0.25. So this box is 2.5. That box would be 2.5. Limit from the left equals limit from the right. So the limit's 0.25. We do not have a function value, so we write undefined. And this would be a whole. Now, since I'm going to give you 2 in a row that have the same table, the same function, but we want a different table. Excuse me, I want to come back down here. I'm just going to go through and delete all these values. Get back up there. And now I'm going to put in the numbers that surround -2. Again, these would be in your table already. So you all would just be copying these down. You don't have to figure out how I got them yet. You just have to be able to enter the numbers as you go. And that's all. So this is kind of the boring part where you just get to watch me type in the numbers. Wrong number. So -1.9. Okay. And I didn't get the negative sign, I tell you. So let me just arrow over so I can put it in. So what do we see now? We're at the vertical asymptote rather than a hole. And we see these are growing in leaps and bounds, multiples of 10. This is heading to negative infinity for the left side, positive infinity for the right side. The infinities don't match, so your answer, of course, for the limits, D and E. There is no function value, so it's undefined. And of course, the discontinuity would be either infinite, vertical asymptote, or unbounded. Okay, now to go over after 3 and 4, we have 5, 6, 7, and 8, or 5, 6, and 8, something like that anyway, 7. They're going to have multiple fractions, and so we're going to get rid of this one now. I just hit the little X and it's gone. And so what do you type when you have a complex fraction? So I'm going to give you in the numerator 1 over x minus 1 minus 1/5. And in the denominator x minus 6. Well, what will we do? Again, we start out with a parenthesis. And now I want to do 1. And I'm going to have a divided by, and notice this will give me the nice horizontal fraction bar. So I have x minus 1. And now I want to arrow over because now I want to subtract 1/5. So 1 divided by 5. Notice it keeps the parenthesis going, so I'm going to arrow out of my parenthesis. And then I'm going to have divide. And my denominator is x minus 6. And so it's given me a beautiful graph that I can see. And I can see there's a vertical asymptote happening at 1, but I don't see anything wrong at 6. So we're going to first start out dealing with and seeing what happens at 6 when we look at a table. Remember, this is a graph drawn by a calculator, not a graph we've given you on a sheet of paper like limits 1. To where when we draw a graph, if there's a hole in it, we have to indicate the hole when we draw the graph. Otherwise, everyone assumes it's continuous. Not so on your calculator pictures. So let's get a table. So go to Settings, choose the little table icon, get down here, and just tell it you don't want these so you can put in your own table. And so I'm going to start with 5. Well, that's supposed to be 5.9, so let me go back. All right, 0.9. And I'm just entering the numbers again that you would see in a table if you were to create, have one given to you. Ooh, what did I do? Let me, okay, so I now have my table, and look, again, they're lining up all over there around our 6. But notice I forgot to put 6 in the table because most books don't put it in for you. So I wanted you to see that I'm looking and it looks like, oh, well, maybe the answer should be okay. But now let me go ahead and put in the 6. Whoa, 6 is undefined. This is why on all of your tables, we go ahead and put in where the function value could possibly be. Because right here, we're saying, hey, baby, that looks continuous without putting the 6 in. Notice the limit from the left is negative 0.04. The limit from the right rounds to negative 0.04, so the limit's 0.04. But there is no function value, and so right there is not a point at 6, There's a little hole. And until calculators put those in automatically, I'm not buying a new calculator. It's not needed. So now we're going to look, besides at the number 6, let's see what's happening at the number 1, which you would not have noticed without drawing it. And so when I put in the table for 1, I will start with 0.9. And again, these tables are given to you right now. And again, we see we're growing by leaps and bounds, by multiples, not by inches, but by yards or miles, if you like. And we can see that the left side is heading towards positive infinity, the right side is heading towards negative infinity. So the limit does not exist. There, once again, is no function value. And so we would call this infinite vertical asymptote or unbounded. Now, you're going to have some problems on the worksheet that are going to require that you use absolute value. And I just want to show you there is an absolute value key here. And there is one that has you type in a square root. That's your square root key on this. But I want to do one more problem. I want to do, I wanted to get rid of that, sorry. I want to do a problem that's oscillating. So with that, we're having a trig function. So over here in functions is where your trig is. There's your stats. There's the miscellaneous if you needed log or something like that. It's there for the ln or log key would be in there. So now I'm just going to do sine. And I'm going to do 1 divided by x. Okay, and so now look at this. See how it's all mushed up there? And they've even got points on there based on the table that's going to appear in a minute that we'll remove. But I just want you to see that this is all mushed up. You can't tell anything. So let's get a table. So I'm going to pick a table. No breaking news for us right now. Okay, and so you can see here's the points. They're nice and continuous here, but in here it's going to be a mess. This is a continuous graph, by the way, so it seems. So it seems. It is right in here, but right in there, not so much. So let's see what's going on. Let's put in some numbers. And here we get back to, that wasn't supposed to go away. Okay, and so we're going to back up one more. And now I'm going to put in some oscillating numbers for this oscillating function. So, okay. Let's get back here. And let me put the 1 on it. And now, and I'm going to put in, no, get rid of that. And I'm just going to put in a few more numbers on your paper. That's as far as we go. But notice how it went from 0.54 to 0.5, then down to negative 0.82. See, these points were plotting at the same time. So boom, 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 boom. Well, that's insanity. All right. So now I'm going to plug in 0 and it's undefined. And so now let's try some numbers on the other side. When I put it in, you saw that just appeared. And then 0.001. Now watch over here as I put the number in. You see another number appeared from a negative all the way up to a positive. So let me watch as I put this one in. It's going to appear. See, it now went back down to a negative. And then let's go to 0.1, and it goes down further negative. It's all over the place. That's what we call oscillating. And when you're doing an oscillating function, this never either goes by leaps and bounds or squeezes in slowly on a number. It's all over the place. D and E, same here, D and E. So the limit is D and E. The function value is undefined, and this one is called oscillating.